Hi everybody, this is my review video for the Unit 5 exam. I'm just going to kind of go over here real quickly a few general topics that you're going to want to study or review over. I think most of you have a really good handle on most of this content. I didn't get very many questions or very many suggestions or anything like that where people really wanted to go over a particular problem, so I'm getting the impression that everybody's really feeling generally pretty good about the material overall. So this is going to be just kind of a general overview of the types of content that you're going to be expected to be aware of and be reasonably competent in. It is not a complete list. That would be really hard to put together. But it is a grouping of kind of the main ideas. So here we go. First thing that you want to be familiar with are the different scientists through the development of electrical theory, what they developed, what role they played in developing either the theories or the equations or any of the technologies, anything like that. So go back and do a little bit of history review and go over that a little bit. You're also going to want to be very familiar with the diagrams. Obviously, you want to know what the different symbols of the diagrams mean. You want to be able to look at a diagram, see what's going on, be able to investigate, okay, you know, what's my current here, what's my voltage, what's my resistance of this circuit? If I were to change this, how would this, you know, affect the overall circuit? You want to be able to read and interpret those diagrams in that way. You'll also need to be very familiar with the concepts of parallel versus series, not just how they're diagrammed, but how do they change what's happening within the circuit? How does that change the current? How does that change our resistance? You know, what does that do to the overall circuit? You're also going to want to have a lot of familiarity with the equations, both from like the equations that you ran into with 5.04 and the equations with 5.15, where we're looking at like E equals F over Q or F equals K times Q1, Q2 over D squared. Any of those equations, you want to go back and review those, get familiar with what each of those symbols talks about, looking at your word problems and going, okay, if I see this type of wording in a problem, this is the symbol, or this is the piece of information they're trying to impart to me. You also want to be very, very familiar with the V equals IR relationship, the Ohm's law equation. That's going to be used extensively, both mathematically and also conceptually, so be very, very familiar with those. You're also going to want to be very familiar with the concept of the inverse square law, or Coulomb's law. You'll see it referred to a number of different ways, just kind of depending on, you know, the terminology that people use. They're the same thing. It's this idea that either gravitationally, which this still holds, or electrically in this case, as charges get closer and closer and closer together, the amount of effect those charges have on each other increases. And in the same way as they get further apart, the amount of effect that they impact on each other decreases. But it doesn't decrease by a direct relationship where I'm twice as far away and therefore it's half as strong, or I should say an inverse relationship, pardon me. You know, but what it is the square of the inverse. So if I go twice as far away, I will be 1/4 of the strength. If I go 3 times farther away, I will be 1/9 of the strength, and vice versa. If I'm twice as close, I will be 4 times stronger. 3 times closer, I'll be 9 times stronger. So you want to really be familiar with that concept. They're not going to have you necessarily do a ton with, you know, solving that. You do that a lot with the F equals K times Q1, Q2 over D squared. You know, that ties in with that Coulomb's law. But they do a lot of stuff with it conceptually. So be very, very, very comfortable with that. Be able to really think through and logic through that problem and those series of problems and really, really consider what's happening here. One problem that we've had with people in the past when taking the exam is it's almost like you're rushing. And so what happens then is, you know, people don't read carefully, and so they don't realize what the question is looking for or where they're trying to go with it, or they don't take it quite far enough, or they put their variables in the wrong places, you know, what have you. There's a lot of different scenarios to happen there. So make sure that when you go to take the test, that you slow down and that you really, really think about it use your scratch paper, really think it through, really work the problems. It's not a race to the end. You don't have to finish in 5 minutes. That's ludicrous. You have an hour, or if you need more time, I can even grant you more time than that to work through the problems carefully and really consider what's being asked. So make sure that you take your time and that you spend that time wisely, really, really thinking things through. Skip those problems that you don't know off the top of your head. If you're concerned about time management, come back to those later. Get the ones that are really easy out of the way so you can get most of the test done. Go back and spend the time then on the ones that are more challenging. Oftentimes you'll find that concepts that you missed, are questions that you're really kind of uncertain of early in the test might be readdressed in a different way later in the test, and therefore if you kind of skip ahead and go to the next one and the next one, you might find, hey, this actually gives me some help here with understanding how to interpret this question. So those are kind of the general topics that you want to hit. Spend some time with them. Go through the material. Take your time with it. Anything like that. If you find at the end of the test, you get your scores back, and you're like, no, this doesn't seem quite right, or I understood the problem to go this way or that way, or I interpreted it a little differently. Remember that you can always reason for points. You can, shoot me an email and say, hey, on the test this one and this one and this one and this one, these are what I was thinking. This is what I was going through. Or, look, I realized I made a math error, or I used the number in the wrong place. This is what it should have been, and this is what it should have looked like, and this is what the answer should have been, and this is why. Then we can talk about giving you back some of those points. So you want to take advantage of that as much as you can, so as to help, improve your score, should you not perform as well as you would like on the exam. So one final quick note. I got a whole lot of work from people over, Friday and the weekend, which is great. But as you know, I was out of town, and so then I spent a lot of time traveling. So now I open up and I've got like tons and tons of assignments to grade. So it's going to take me a couple of days to kind of dig my way out of that. And so sorry about that. If you're taking the test here in the next day or two, I would love to have that back for you, but it's just not realistic that I'm going to be able to get everything graded all at the same time. So I'm trying and I'm working on it, but it might take me a couple of days. So please be patient. All right, guys, I hope that was helpful. I hope that gave you a good sense of kind of what you want to kind of go through, where you want to spend your time, what's going to be important, what's not going to be important. Problem solving is going to be a big part of it. Diagrams are going to be a big part of it. Coulomb's law, that inverse square law, that's going to be a big part of it. So spend your time there and really practice those skills. And I hope you guys have a great day and good luck on your exam.